Your bird is sitting by an open window. For 1 second, nothing happens. Then, a truck bangs outside. The bird jumps, and the room is suddenly empty. You run downstairs with the cage. You shake the treat bag. You play the recording. It always answers, somewhere above the roofs. A small shape crosses the sky and disappears. Then comes the thought you do not want to admit. If it loves me, why doesn't it come back? This bird knows your voice. It knows which cupboard contains the good food. It may scream when you leave the room and climb onto you the moment you return. A pigeon can be released far from home and still find its loft. Wild birds cross continents. Your bird only needs to find one apartment, so perhaps it chose freedom. Perhaps all those affectionate noises meant less than you thought. Or perhaps a bird can know exactly who you are and still have no idea where you are. There is surprisingly little controlled research on escaped parrots themselves. Scientists cannot responsibly release people's pets over cities and wait to see what happens. But studies of parrots, pigeons, migratory birds, flight development, and animal navigation let us reconstruct the problem. The first clue is uncomfortable. Love is not a map. Pet birds can form real social relationships with humans. That does not mean every head scratch is a lifelong oath of loyalty. Birds also learn routines, because routines bring food, safety, attention, and access to interesting objects. Still, the relationship is not imaginary. Parrots are intensely social animals. Many species normally spend much of their lives around mates, family members, or flocks. In a home, people can become part of that social world. The bird calls when you vanish because keeping contact matters to a flock animal. One odd study made this visible through video calls. In 2023, researchers led by Kleinberger worked with 18 companion parrots. The birds learned to ring a bell, choose another bird on a tablet, and start a call. They were not forced to sit through someone's office meeting. Many chose to make calls and stayed engaged with the bird on screen. So an escaped parrot may want familiar company. It may recognize your voice. It may even hear you. But recognition solves only one problem. That is my person. Returning home requires another answer. Where is my person relative to where I am now? Humans blend those questions together because we carry addresses in our phones. The bird does not. The confusion usually begins with pigeons. A homing pigeon can be placed in a box, driven to an unfamiliar release site, tossed into the air, and still head toward its loft. That makes bird sound like a device category with built-in navigation. It is not. Homing pigeons descend from rock pigeons, which naturally return to stable nesting sites. Humans spent generations breeding reliable returners and training them from increasing distances. The result is closer to a racing animal built around one strange talent. Even pigeons do not simply point at home with a magical internal arrow. Experiments suggest they combine a broad map with a compass. Depending on the place and conditions, they can use odors carried by regional winds, the sun, magnetic information, and familiar landmarks. Near the loft, experienced pigeons become surprisingly ordinary. GPS studies have found them following roads and railway lines. Some keep using a familiar route even when it is longer. A bird can possess a magnetic sense and still commute like your uncle. Your parrot was probably not bred for this job. More importantly, it may never have built the local map that the job requires. And a home seen from inside is a very different place from a home seen from the sky. Think about what your bird actually knows. It knows the cage from half a meter away. It knows the window from the sofa. It knows the sound of your key in the hallway and the angle of sunlight on the kitchen floor. Those memories work inside the apartment. From above the next block, none are visible. An indoor bird may never have circled the building, watched the roof change from different directions, or connected the balcony with the streets and skyline. The apartment is familiar. Its position in the larger world may not be. Navigation researchers often distinguish a compass from a map. A compass tells an animal which direction it is moving. A map helps it estimate where it is relative to a destination. Some birds inherit rough directional programs for migration. Experienced migratory birds can learn to correct when storms or researchers push them off course. That knowledge grows through movement. In a 2007 experiment, Thorup and colleagues moved white-crowned sparrows about 3,700 kilometers across the United States. Young birds largely continued along their inherited direction. Adults corrected toward their normal wintering area. Experience had changed what the adults could do. Your bird may have wings, a compass, and excellent memory, yet lack the thing people assume comes free, an outdoor map centered on home. Then the window opens, and the bird does not begin a navigation test. It panics. A frightened bird may fly hard until it finds somewhere high enough to feel safe. Wind can carry it farther than expected. Minutes of flight can turn one familiar window into thousands of similar windows. Now the bird has several problems at once. It must control its body in open air. Indoor flight is full of short trips between known landing spots. Outside, there are gusts, traffic, wires, reflective glass, unfamiliar birds, and predators. A bird with clipped feathers, weak flight muscles, or little outdoor practice may struggle to turn, descend, or choose a safe landing place. Going up is often easier than coming down. Owners sometimes find a bird sitting in a tree, calling desperately yet unable or unwilling to descend through branches into an open space. From the ground, this looks absurd. From the bird's position, dropping toward a large animal with no cover may feel like a terrible plan. Hunger does not automatically lead it home either. Hunger may push it toward visible food, other birds, water, or human activity. Each move can carry it farther from the last place where it heard you. It did not calmly compare freedom with affection. It may simply be solving the next 10 seconds. Suppose the bird calms down. Could it use the sun or Earth's magnetic field possibly? That answer is less useful than it sounds. Many birds can orient using the sun, stars, polarized light, or magnetic cues. The exact mix varies by species. Scientists have strong behavioral evidence for magnetic sensing in several birds, although the receptor mechanism is still debated. But knowing north does not tell you which beige apartment contains your breakfast bowl. A compass helps when it connects to learned geography or an inherited route. Fly southwest can guide a migrant toward a wintering region. It cannot identify balcony 14B without a local map. The same problem applies to smell. Homing pigeons appear able to learn regional odor patterns from winds around their loft. That learning takes exposure. A pet bird that has spent years breathing filtered indoor air beside a scented candle has not necessarily built an odor map of the city. Your voice is also a weak beacon. It fades with distance, changes between buildings, and gets buried under traffic and wind. Even if the bird hears it, sound may reveal a direction only briefly. The bird could be close, it could be trying, and the human city may be feeding its senses bad information. Cities were not designed for a nervous animal navigating at bird speed. Glass reflects sky where no sky exists. Rows of buildings repeat the same shapes. Traffic masks contact calls. At night, artificial light can pull migrating birds away from their routes and keep them circling illuminated structures. In 2017, Benjamin Van Doren and colleagues studied the 11th of September memorial lights in New York. On illuminated nights, large numbers of migrating birds accumulated around the beams. When the lights were switched off, the birds dispersed within minutes. Your escaped parrot is not necessarily migrating, and one dramatic light study does not explain every lost pet. It shows something important though. A bird's navigation is not invincible. Human signals can overwhelm or confuse systems that work well in natural settings. The city also blurs the difference between near home and almost near home. One roof leads to another. The bird may recognize a park or church tower without knowing where to turn next. Some escaped parrots do return quickly. Some are found nearby after days. Others join free-living parrot groups where climate and food allow it. Many outcomes never enter a scientific database, which is why confident percentages online should make you suspicious. We can describe the obstacles. We cannot look inside one missing bird and know which obstacle won. There is another twist. Humans can become part of a bird's navigation system. In social species, routes can be learned from older or more experienced birds. Thomas Mueller and colleagues analyzed reintroduced whooping cranes in 2013. Groups containing an older bird stayed closer to the migration route, and individual performance improved with age. Humans took this idea to a strange extreme. Conservation teams used ultralight aircraft to guide young cranes along a migration route. People wore costumes while raising the chicks, then climbed into a flying machine and acted as an unconvincing adult crane. It worked because migration can contain learned, social information. The route was not sitting fully formed inside each young bird. That gives us a better way to think about pets. A home is not automatically a coordinate in a bird's brain. It becomes reachable through experience, looking at it from outside, flying away and back, learning nearby landmarks, and building confidence in outdoor flight. This is why free flight training is specialized and risky, not a test of love. The bird must learn recall, outdoor conditions, and local geography. Even trained birds can be lost. Affection may provide the reason to return. It does not provide the route. So why did your bird not come home? There may be no single answer. It could have been carried out of its familiar area. It may have landed close by and become too frightened to descend. It may have recognized your calls without being able to locate their source. It may have followed food, other birds, or the first safe-looking tree. Injury and predation are also possible. What we should not do is turn absence into a verdict on the relationship. A parrot can miss you and remain lost. It can know your face more clearly than it knows the shape of your neighborhood. It can possess senses humans do not have, and still fail at a journey a trained pigeon might complete. That is hard to accept. We imagine home as one thing. To us, it is a person, a room, an address, and a point on a map. For the bird, those pieces may never have been joined. Inside the apartment, you were easy to find. You were the footsteps in the hall, the familiar voice, the hand holding breakfast. Outside, you became one quiet point behind concrete, glass, traffic, and miles of unfamiliar sky. The bird did not need a stronger bond. It needed a way to turn that bond into a direction.